When you conduct hypothesis tests following the Z procedure, T procedure, or proportion, you often have to answer this question. Explain what the p-value means for this problem. The definition of p-value is the probability if the null hypothesis H0 is true, the test statistics from another random sample will be as extreme or more extreme as specified in HA than the test statistics observed from the given sample. So when you read the problem statement, they will introduce what the population is, and then in a proportion problem, they will give you a sample size and then tell you the number of success, and then you can write the sample proportion p hat that is equals to the number of success x1 divided by the sample size n1. So according to the definition of p-value, there is a chance equal to the p-value. The p-value is a probability, right? So there is a chance equal to that probability. Here is what I can do. I can take another random sample. So I call that N2. And then in this random sample, I have the number of success x2. And then I can write my second sample proportion p2. And then can you describe the relationship between, can you compare p1 and p2? Based on the definition of p-value, we say p2 is more extreme than p1. What do you mean by more extreme? Big, really, really big, or really, really small? To answer this question, big or small, you have to look at the sign of the alternative hypothesis. So that's why in the first note in red, I said the description of more extreme is based on the inequality symbol of HA. So when you set up your HA, you either use a not equal, a greater than, or less than. So there are three cases. And then in this video, I will explain each of the three cases. And then before you go into the first case, when you see the color code in blue, so light blue, I said there is always an equal because we assume H0 is true. So if you look at the first line of the definition, we assume the null hypothesis H0 is true. And then there are two more numbers that you have to pay attention to, the p-value and the sample proportion. So in the next line, I said the number in the square bracket is based on p-value and the sample proportion. So the underline is based on the problem. So I'm trying to generalize the answer. So regarding what the problem is trying to tell you, you have to fill that into the underline, and then the square bracket is for you to fill in the p-value and the sample proportion of the problem you are solving. So you have a problem right in front of you, right? And then what that problem is about, that you have to fill that into the underline, and then the p-value and the sample proportion of that problem, you have to fill that into the square bracket. So let's take a look at the first case. The first case is a left-sided test. So left-sided test, there is a less than symbol in HA. So I have an example for you. So I said P0, the H0, P is greater than or equal to 60%, and then HA is the opposite. So the opposite of greater than is less than. So this is a left-sided test, and then I gave you a p-value 0.0745, and then I also gave you a sample proportion p hat that is 110 out of 200. So based on this, you can tell that 110 is x1 and then 200 is n1. They introduce a sample size, right? And then they gave you the number of success in the sample size. So x1, n1, then you have your sample proportion p hat. So how do you explain the p-value? The p-value in the first case is equals to 0.0745. What does that mean for this problem? So here is the explanation. If H0 is true, you always have to start with this. If H0 is true, there is a chance equal to the p-value. This is correct in every single problem. It doesn't matter which side you are doing. You start with, if H0 is true, there is a chance equal to the p-value, and then you fill in the p-value to the square bracket. So if the problem you are solving has a p-value 0.0065, then you fill that into the square bracket, and then continue that the sample proportion of what? The sample proportion of, you have to read your own problem and then tell me what the sample proportion is about. So I am trying to generalize an answer for every single less than problem you are solving, for every single left-sided proportion problem you are solving. So the sample proportion of an underline, you have to read your problem and then fill in the blank, is less than, so the less than follows the sign of HA. And then what about the equal to? This, you have to follow the color code. Do you see that in H0, I have an equal in blue, and then when I write the explanation, I have the equal to in blue. So we have to take the equal to from the H0 Y, because you start off with if H0 is true. So when you say if H0 is true, then there is an equal. So that's why you have to add the equal to the inequality symbol of HA, which is less than or equal to what? Less than or equal to the sample proportion you have from the problem. So I can grab another sample proportion, and that is less than the one you have in there. And then in case 2 is a right-sided test. So right-sided test, we have a greater than in HA. So the H0 I have is the proportion is less than or equal to 50%, and then HA I have a greater than, and then the p-value is around 0. It's a little bit greater than 0, but I would just say it's around 0. And then the sample proportion p hat I gave you is 200 out of 300. So 200 is your x1, and then 300 is your n1. They gave you a sample and then told you the number of success. So how do you explain the p-value? The 0. The p-value equals to 0. So here is how you start with if H0 is true. You always have to start with if H0 is true. This is required. And then you say there is a chance equal to the p-value, and then you fill in the p-value. Whatever p-value you have in your right-sided problem, you fill that in, that the sample proportion of what? This is based on the problem you are solving. Is greater than, so I took the greater than straight from the HA, and then what about the equal to in blue? You assume H0 is true, there is an equal in H0, so that's why you take the equal as well. So basically you have to take the inequality symbol of the HA plus the equal. Equal to what? Equal to the sample proportion you have in the problem. So that is for the right-sided test, having a greater than in HA. The last case is the most complicated. The last case is the two-sided test. Two-sided test means you have a not equal in HA. So why do I say not equal is a two-sided? So let me just give you a simple statement. So let's say your age is not equal to 20. What does that mean? So that means you can picture this in your mind. So you have a number line, and then you have a 20 years old, and then not 20 years old, then you put a big cross in here, right? So not 20 years old. That means your age is either greater than 20. So your age is either greater than 20, so which is like 21, 22, or less than 20, 19, 18, so on and so forth, either greater than 20 or less than 20. So that is what makes the not equal two-sided. You have a line, you don't want to take 20, then you either take something on the right side or you take something on the left side of the 20. So my H0, I have an equal. So H0 is equals to 75%, and then HA is the proportion is not equal to 75%. I gave you a p-value, and then I gave you a sample proportion, 70 out of 100. So this one you have to pay attention to this, because this you have to do some work to get the numbers in the explanation. So if H0 is true, always start with this. If H0 is true, when someone asks you to explain the p-value, it doesn't matter which procedure you are following, proportion, Z or T, the first thing that you will have to write down on your paper is if H0 is true. Always start with this. Then you say there is a chance equal to the p-value that is the same in every single problem, and then you fill in the p-value. So whatever the p-value is, and then you bring it over there. I should add a square bracket over there as well. So the p-value is 0.2482, that the sample proportion of underline, so underline the sample proportion of what you have to take that description from the problem you are solving, is less than or equal to 0.7, greater than or equal to 0.8. If you take a look at the H0 and HA, there is no 0.7, right? I mentioned 0.75. Even though you say, all right, your sample proportion p hat is 0.7, then you put the 0.7 in there. But that leads you to the next question. Hey, what about the 0.8? I don't see where I really don't know where the 0.8 came from. And I mentioned less than or equal to 7 or greater than or equal to 0.8. So this is the inequality. So the sample proportion is less than or equal to 0.7, or the sample proportion is greater than or equal to 0.8. All right, so here is how you figure out these two numbers. So first of all, you have to write the given sample proportion. You read the problem, right? They gave you the number of success, which is the x1, and the number of and the sample size n1. So you have to write the sample proportion x over n, and then you approximate that to fractions. So 70 over 100, that is equals to 0.7, and then the one they propose is 0.75. And then you draw the following picture. The one they propose, you put that right in the center. And then from 0.75 to 0.7, how much do you have to subtract? The answer is you have to subtract 0.005. So that is how you take one step to the left. And then since you take one step to the left by subtracting 0.005, when you take another step to the right, you have to add 0.05, right? So 0.75 plus 0.05, that is equals to 0.80. So 75 plus 5 is equals to 80. So that's how I got the 0.7 and the 0.80. So if you take a look at the arrow, so it's either greater than or equal to, so the p hat is either greater than or equal to 0.8 or less than or equal to 0.7. So the extreme means you either go all the way to the right, make the p hat so big, or you go all the way to the left, make the p hat so small. So it's either greater than or equal to, that means the right side, less than or equal to, that is the left side. And this is how you figure out the two numbers in your explanation. All right, so that is the end of this video. If you think my instruction is helpful and clear, please give me a like, share the video for me, subscribe to my channel. I will see you all in the next lesson. Signing out for now.